In this video, we are going to find missing angles in a right-angled triangle using our trig ratios. So if you think about it, great teens, yes, we can find missing side lengths using Pythag easily, but we have no way to find a missing angle because sum of angles of a triangle is not going to help us because we don't have enough information. And that is where trig comes in so handy. So let's jump in and do that. So the key thing with these sums, grade 10, is just to figure out which trig ratio am I supposed to use. And let's do that. So our missing angle over there, we know that is theta. That is our angle A. So it's not going to benefit us if we try and use the opposite, because this would be our opposite, right? Let's just quickly label it. If we position there, this will be our hypotenuse always because it's opposite the 90-degree angle. This would be our adjacent to our angle A. And this would be the side opposite that angle A. So we're not going to use the opposite sides because we don't have it and we're not looking for it. So we're not going to bring that into the equation that we're going to build. So we're not going to use opposite. Well, if we position at A, then we've got adjacent and we've got the hypotenuse. So based on that, that helps us determine what ratio we're going to use. So think about that, adjacent and hypotenuse. And this is all new, so you will get used to it. But that would be cos. Cos theta is equal to adjacent over hypotenuse. Now let's go plug those in. Cos theta is equal to, my adjacent is 5 centimeters, my hypotenuse is 7 centimeters, and that's it. Now we can find theta. Remember the calculator work that we did in one of the previous videos? We need to let the calculator know that we are not giving it a ratio, we're not giving it an angle, we are giving it a ratio of sides. So into your calculator, you would put shift cos. So now the calculator knows that you're going to give it a ratio of sides, which is the opposite over adjacent. So I'm putting into my calculator 5 over 7. And then the calculator spits out an angle for me. Therefore, my angle is 44,12 degrees rounded off to 2 decimal places. And there we found this angle. 44,12. And then, grade 10s, we can use sum of angles of a triangle or trig ratios again in order to find angle B. We can use trig ratios or we can use Pythag to find the side length of BC. Okay, let's go over to number 2. Let's see where theta is there. So we're supposed to find a missing angle in this 90-degree triangle. Again, we can't use sum of angles of a triangle, but we can use trig, and that is why trig is so handy. Which ratio are we going to use? Well, what we're given helps us determine that. We've got our hypotenuse is that side over there. Oh, that's blank. We're not given that. We don't want that. So we're not going to bring that into our equation. If we are there at angle D, this would be our adjacent side, and this one would be our opposite. It is opposite angle D. Okay, so in other words, we don't have hypotenuse, we do have the adjacent, and we do have our opposite. So those are the two that we need to use. Let's build an equation. What is it if we're going to use adjacent over hypotenuse? That must be tan. Tan theta is equal to opposite over adjacent. Let's substitute that. Tan theta, my opposite is equal to 5. My adjacent is equal to 4. Calculator work, we need to let the calculator know that we are not giving it an angle. We are giving it a ratio of sides. So into your calculator, you tell it shift tan, and then we give it that ratio, which is 5 over 4, opposite over adjacent, and then it spits out the size of the angle. So therefore, my theta has a size of 51,34 degrees rounded off to 2 decimal places. So we just found that angle. Trig helped us to find a missing angle by using the ratio of the sides. Now we can use sum of angles of a triangle to find that. We can use trig or Pythag to find the hypotenuse, whatever you prefer. Okay, there's one more. All right, we need to solve that angle, angle theta. So we are positioned there. And let's see which trig ratio is going to help us. We've got the hypotenuse. It is opposite the 90-degree angle there. We've got that one. We've got from theta, we've got the opposite side length there. And we do not have the adjacent side length. So we're not going to bring adjacent into the equation that we're going to build. It's not going to help us because theta is already the missing thing that we are trying to find. Which ratio are we going to use? We don't have the adjacent. We do have hypotenuse and we do have opposite. We're going to use sine. Sine theta is equal to opposite over hypotenuse. Make sure that you go learn these. And then let's substitute. Opposite is equal to 3. Hypotenuse is equal to 8, which is always the longest side. Now we just need to tell the calculator we are not giving you an angle. If we did, we would just put it in sine and then whatever the angle is. But we now need to let the calculator know that we are giving it a ratio of sides. So into the calculator, we are going to say shift sine, and then we put in 3 over 8. And then it gives us that theta is equal to 22,02 degrees, and we just found that angle over there using our trig ratios. Then we can go ahead and find that. If we were asked for it, we can use Pythag to find that, or we can use trig ratios to find it. I would suggest trying some of these on your own, where you have to solve angles in a 90-degree triangle using your trig ratios.